Do you remember these? Or this? Do you remember this thing? Do you remember going to a restaurant as a kid and they'd give you one of these? And they'd give you that box with like 4 crayons in it and they'd be really shitty, but on the back of that thing they had a maze. I really liked that maze. You know what's really good at solving mazes? Computers. So today, we're going to be building a maze solver. To represent our maze, we will use a two-dimensional array. For blank squares, we can leave them with a 0 in it. And on our website, that looks like this. The next thing we need to do is build our maze. And so we need to put the walls in. We can represent our walls with a -1. Like this. On our website, that looks like this. And the last thing we need for our maze is a place to start and end, which we can represent with 2 and 3. And we have a maze. It looks a little gross in numbers, but on our website, it looks like this. So the first thing we want to do is create a queue of places that we want to go. I like to think of a queue as people in line at a grocery store. The first person who gets in line will be served first, then the person behind them and the person behind them. So in our queue, we want to start by queuing up our starting location. So I'll just call that S. So now that we have a queue of places to go, let's store a current place. So currently we have a current, but we're not anywhere yet. So what we can do is we can set our current to be the first thing in our queue. So now we are at S, our current, and we have no more places to go. So if we have no more places to go, well then we've solved the maze. Well, we haven't solved the maze yet. So let's see, where can we go? From S, we cannot go up, we cannot go left, and we cannot go right because there's a wall, but we can go down. So we'll call this A. And A, what we want to do is, because we can go there, we will add it to our queue. From here, we have completely visited S, so we can mark it as visited. And then we can visit A. So now we have visited S, we are now at A, and we can just repeat those same steps. So now we figured out that we can move to B, and we'll move to B. We do the same thing at B, and then we can move to C. So now that our current is C, we'll find that we actually have 2 places that we can go. We can go to the side and we go down. Well, although it sounds a little bit more confusing, all we have to do is get both of these places in line in our queue, and then visit them the same way that we've been visiting everything else. So now we found that we can move to D and we can move to E, so we can just visit those by doing this, setting this to be D, finding out that we can go here, and so on. And as we do that all the way through, we'll see that we will search the entire searchable area. And in that searchable area, we will find the end. So the code for this shouldn't be too hard. We have defined our starting point to be here. And so the first thing we need is to have some sort of queue for us to store the places that we want to go, and then we want to put our start into that queue saying, visit me first. So now we have our queue. This will allow us to store the places that we want to visit in the items. We can push a new item into our queue to say we want to visit here, and then we can pop an item off of our queue to visit that location. We have now pushed our starting index, so the place that we want to start, onto our queue, saying visit the start first. So the next thing that we want to do is to solve our maze. And we're going to do this one step at a time. So at each step, we need to visit a node, and we can do that by popping off our queue. Then we need to figure out all of the places you can visit from that node. And then we want to take those places and push them onto our queue and say, visit me next.
Nice.
So this code solves the next step in our maze. It says if there is a place for us to go, then we want to go there. From that new place, we check, can we move down? Can we move right? Can we move up? And can we move left? If we can move in any one of those directions, then we want to add that direction to the place that we want to visit next, and then we want to mark it as a place that we visited. This helps us avoid visiting the same place twice and getting stuck in an infinite circle. So if we come back to our website and we draw a little maze here, we can watch what happens as we go to explore. Hitting the solve button will move us one step further, so we can see that this is the first place that we visit, and then we visit these next two spaces. And as we keep clicking solve, we can see that we continuously explore more and more of our maze. So this will explore the entire area that it can, and eventually it will find the red square. The problem is right now, when it finds the red square, nothing happens. It just stays there. So we need to figure out something to do to tell it, hey, once you've found that red square, you're done. It's also very satisfying to just let it run and fill in all the spaces. find the end, we need some way to say, trace back the path that you used to get here. Right now, we are exploring the whole area, but we're not saving our path. We're just exploring, and once we find it, we stop and we say, wow, we're here, we've stopped, but we don't have a way to trace back to the start and highlight that solution. So if we traverse this maze in the way that we've been traversing it, using the A, B, C method, we'll get something like this, where we first search A, then B, then C, then D, then E, then F, then G, and I guess this should be H, but we'll just call it Z, doesn't matter. We will search and we will fill up the whole area. And there is a path here, I won't really draw, there's a path here to the end, but we don't save that, and when we find the end, we don't have a way of showing this off. So what we can do is, as we're traversing the maze, we can somehow store that path. So we start at S right here, and then we move to A. So what we can do is we can store that A maps to S, meaning A, we got to A from S. Then, after that, we will visit B, and we can store that B we got to from A. And then the same thing with C. C we got to from A. So then we have C. And if we do this for the rest of our maze, it looks like this. So we have traversed our maze, and for any given cell, say H, we can determine where we were when we visited H. So we can say H, we got to from G, and G is right here. So from our P, we can say that if we start at P, how did we get to P? We got to P from N, and then we got to N from L, using this, and then to L, we got from K, and then to K, we got from J, that's here. And if we do that all the way back, and A, well, now we have a path that if we follow P to N, to L, to K, to J, to I, to H, to G, to E, to C, to A, we know that A, from here, goes back to the start. So once we find our ending location, all we need to do is figure out the path to how we got there using these, and then once we map out that path, we can just traverse that path, and we can mark it as green or something to show that that is the path to the solution.
So the first thing we need to do to present our maze solution is to create an object to store our dictionary of to and from, as we just showed on the whiteboard. And we can do that by creating a new object. And then we can access this object like this. So we can say dictionary dot from, or dictionary dot to equals from. And we will do that each time we add something to our visit. And that will look something like this. So basically what this code does is whenever we are going to push a place, so current of x to current of y plus 1, we just note in our dictionary that that location was accessed from our current location.
If we hop back into our website and we open up our developer tools, we can see what happens as we traverse our maze. So if we add a little wall here, we can see that when we solve, we can see that this first square, 0, 1, was accessed from 0, 0. If we hit solve again and we explore 0, 2, we can see that 0, 2 we found from 0, 1. The same thing will keep happening as we explore and explore. And our dictionary over here of where locations were found from will be stored here. And we can continue to do that until we find the endpoint. Once we find the endpoint, we will have a full path within here to show us how to get back to the start. And all we need to do is highlight that path to show the user there is a completed path.
So the last thing we need to do is, if our maze is solved, then we want to display our solution. And we can do that by starting at our end variable, and then finding that within our dictionary, finding which node got us to the end, and working our way backwards through that path. That looks something like this. So it's actually very simple. All we need to do is we take our current endpoint, which will start at the very end of the maze, and we will mark that as green, which we represent as 2. And then we say, from that endpoint, find me the node that got me here. So that happens within our dictionary call. And then we set our end to be the node that got us to the end. Then we set that new node equal to green, and then we update to find the one before that. The last thing we need to do here is we need to add a check that says that our ending.x does not equal our start.x, and our end.y does not equal our start.y. And this just checks to say, if we are at the start of the path, don't go any further. So if we hop back in our maze solver and we draw a simple maze, we can see that when we solve it, it goes blue and then comes back up green, showing that solved state. We can see that if we have a more complex maze and we solve, it will only highlight that winning path, and it will leave the other ones blue to show that they were explored, but they were not part of the solution. So to recap this project, we have a two-dimensional array that we can set values to be -1 to represent walls. We then have a queue, which will store the places that we want to visit, which we will then go visit. So we will queue up that starting node, and we will say, visit the next node. From there, this will find all the visitable nodes, which would be the one below it, and then visit those nodes. This will then repeat that process, finding that it can visit to the right and down, and then visit those nodes. As we do this, we store the prior node. So when we visit this node here, we will store that we visited it here from here, so that when we find the end, we can mark that this node was visited by this node. And we can backtrace that path to highlight the successful winning path that solves the maze. I hope you enjoyed this project, and I hope you like to watch it in action.